Hi everyone, welcome to Petroleum Software Online Training. Today I'm going to introduce to you and to start, we are going to start our class, our practice class, our first practice class, where I'm going to teach you about using Petrel. But before, we need to know what are the data required to be imported in order to create a model. As we know, we're going to use Petrel software. So this is our second lecture. As the first lecture, I was just introducing about oil and gas reservoir. So introduction of this lecture is Petrel software. It's used to create a 3D reservoir model. So today I'm going to introduce for the new users of Petrel function with the emphasis of visualization, data organization, and the collaboration. So we are going to see how you can create or organize your data in order to start using Petrel software. The course also will cover basic usage of the application. In this course, I'm going to provide an understanding on how to get started with Petrel. So is from my website. Every one of you, I think each of you have already downloaded the software. So in this class, I'm going to show you how will you get to start using the software. You will learn also about Petrel project setup, data importing and visualization, creating simple surface. But for this creating simple surface, grid and performance-based quality check, we'll do them to our next classes. But for today's class, we'll be about organizing our data and also how to import data into our Petrel. So before we start our class, let's now start by reviewing what is reservoir modeling. So in oil and gas industry, reservoir modeling involves the construction of computer model of a petroleum reservoir for the purpose of improving estimation of reserves and making decisions regarding the development of the field, predicting future production, placing additional wells, and evaluating alternative reservoir management scenarios. So these are the purpose of creating a reservoir model. So and as we have said, like the advantage of using or creating a creating a reservoir model, it just gives us an understanding of the reservoir. A full suite of the reservoir characterization tools enable geoscientists to develop stratigraphy and structural reservoir understanding and move the seamless from 2D maps to 3D map, providing accurate throughout the exploration and development and production life cycle. So as we've said, you can create a model and move the seamless from 2D map to 3D map. As you can see, these are the structural hydrocarbon traps. So through using Petrel, you will be able to create something structural hydrocarbon trap like this one, and stratigraphy oil trap. You can create all of them by using Petrel software. So this is just an example. As you can see, the upper side here, we have a 2D map. This is a 2D map which will be used to create a 3D map. As you can see below here, this is the 3D map. So building a 3D reservoir geological model is to examine different development plans for respective fields. Also, the objective of creating a reservoir model is for calculation of initial volume in place, optimization of drainage strategy for a hydrocarbon field, calculations of recoverable volumes, generation of production profile, evaluation and generation of depression plans as the plan tools of developing placement of the production and injection wells. So all these are just the objective of doing reservoir modeling. So another objective, as we know, that digital reservoir models may serve different purposes, and we typically distinguish static reservoir model and dynamic reservoir model. So I'm going to explain to you the different types of reservoir model. So there are several types of reservoir model. So the first one, we call it as a geological model, or sometimes we call it as a static model. Also, the second model is called reservoir simulation model. So these are the two types of reservoir model. But for petrol, we are going to create a geological model, which are created, mostly they are created by geologists, geophysics, and the aim of this is to provide a static description of the reservoir prior to the production. So this is the basic, and this is our objective of creating a reservoir model, a geological model. So we are just giving a model which is static. It is a static model, so we'll just see all the description about our reservoir. But once you create a reservoir simulation model, these are always mostly created by reservoir engineers and use finite difference methods to simulate the flow of fluid within the reservoir over its production life cycle. So for geological model, for us, our main intention, we are going to create the static description of the reservoir. So one of the static description of the reservoir is oil in place. So once you calculate the oil in place of a certain created model of a certain reservoir, that is a static description of the reservoir. But for reservoir simulation model, for them, these are models which can predict even the future production of the reservoir. So once you create a geological model which will give you a static description of the reservoir, and one of the static description of the reservoir is like initial oil in place. So once you know the initial oil in place, now you can try to calculate the future performance of that reservoir. So when you start to calculate the future performance of the reservoir, that kind of model which will be created there is what we will be calling as reservoir simulation model. So for reservoir simulation model, it just give a future production or future performance of a certain reservoir. So as we are going on together in this class, I will show all this difference. But for geological model, we'll mostly use petrol software, and for reservoir simulation models, this kind of model can either be built by petrol, and the simulation part will be run by another software which is called Eclipse, and Eclipse is one of the software which will be conducted into our class. So by beginning, we are going to start with petrol, and the kind of model which are going to be built are geological models. So that's all. So what are the steps of creating a new static model or a new geological model? So there are several steps. So these are the steps which can lead you to create a new static model. When starting a new project, Petre organized the input data in the input pan. So the following steps are required to build a 3D geological model of a petroleum reservoir. First, you need to have data. So data are the first thing you need to have in order to create a geological model or a static model. So you have to do data import. You have to import your data into the software. But before you import data to your software, data input, you need to do editing, or you need to organize your data. Once you finish to organize your data, then you import your data. There are several kind of data which are supposed to be imported to Petrel software. So all of this we're going to see them today. So the next step, the fourth step, is fault modeling. There is also pillar grading. There is vertical layering, geometric property modeling. Once you finish that one, you are going to do upscaling in the vertical direction and well logs upscaling. Everything I'm going to explain them in our next class. And also we have faces modeling. Also there is petrophysical modeling, and we can define also, when you are building a static model, you can define the fluid contact. Also the last the last procedure when we are creating a static model is volumetric calculation. So now let's see first how you can prepare your data and what are the data which are supposed to be imported to our Petrel software. So these are data preparation. In this instance, data arrangement is as follows. So the first required data you need to import to Petrel software when you are creating a geological model are the one we call as wellhead data. And this here is an example of a wellhead data. As you can see from here, you can look at my cursor here. At this place there is wells. This is the well name. So for example, from here we have 1 2 3 4 5 6 7 8. We have 8 wells in this oil field. We have 8 wells, and then this is within the wellhead data. Also there is symbol is also in each well there is a certain symbol. For example, here we have well number 4132. The symbol, its symbol is 19, and for the well for number 602, its symbol is 03. Also in each well there is a symbol, and this symbol, what are they stand for? And this symbol are stand for the kind or the type of a well. For example, I will show you also. For example, symbol number 19, it may stand for injection well. So once you see this kind of symbol, when you are using Petrel software, automatically the software will define this kind of symbol. So for this symbol, it will just say maybe it's this symbol is symbol number 19, maybe it's an injection well. So for the symbol number 3, you may find it maybe production well. And also well number 5510, number 19. So this every symbol will be standing for a certain particular activity of a well. So 15, maybe it is a development well. So it depends with the kind of symbol you have. So we have like 3 symbols here which are standing into our 8 wells. Also when you come here, there is X coordinate. So this X coordinate, it stands for a location of a well, a location of this well. And Y coordinate is, we know every one of us, like coordinates. These are the coordinates of the well. So well number 41, the first well, it is situated in this coordinate respectively to all the wells. So also we are going to have something called KB, and also we have MD. All of these I'm going to explain to you what are they standing for. So this is the first file you need to have when you want to create a geological model. So these are the basic or are the key requirements you need to have while you want to create your geological model. So these are the data. So the first data you need to have is wellhead data, and within this file of wellhead data you need to have this kind. It's supposed to be elaborated in this kind of data. So all this calculation will be explaining about the data. So this is another example of wellhead data. For example, as I've said, we have well name. So these are different kind of well names. We have X coordinate, Y coordinate, we have Kelly Bush or KB, we have top depth, and we have bottom depth. So all this information are regarding to the particular or are regarding to the information about the well from the top to bottom. So now let's see the well attribute description. For the well name, it just stands for the well name. For well symbol, as I've said, well symbol, it just stands for the symbol of the well, a function of that well. There is surface X, that is the X location of the well at the wellhead. and Y also it stands for the Y location of the wells at the wellhead. Also KB, or the Z value of the Kelly bush. This is what we call a Kelly bush. I'm going to show you a picture on how you can define all of them. So we have TVD or TD, the vertical depth value. Also TD or MD. For this one, we call it as the measured depth. So all these are just data which are supposed to be explained into our project. So here it's a vertical measurement in petrel. So the vertical unit in petrel can be measured in numbers of different ways depending on the data being described. So for example, when you come to this picture on our right hand side, you can see KB. This is our wave from and it is in the onshore sink, offshore or offshore, yeah. So for example, this is our well. This is our well, and the depth from top here to the end value and end point of our well, this is what we call a KB. And for measured depths, it's from here at this red button, red color, to up here. So this is what we call MD, measured depths. And also we have Z. So the Z is just taken from the sea to the sea upper to down here, to the down level here. So this is just a description which shows you what are the kind of data which we are going to be using them while we are using petrel. So join with me and you will continue to see different kind of data and how are they used. So data required to be built to build the model. As I've said, the following table describes different types of input data required for petrel along with their format and type. So for example, we have said the first data which is required for you in order to create or to build a model, you need to have well data. Well data is the first kind of data which you're supposed to have in order to create a geological model. So as you can see, for well data, you have wellheads. We just finished to explain about wellheads. We have well deviations and we have well logs. So all these are data which are in the first batch. Like once you want to create a model, you need to have wellheads, well deviation, and well logs. And here are the format. So this format will help us when we want to import this data. So I will show you where is the use of this kind of data. So for today, we are going to import data from. We are going to use wellhead headers, and we are going to use also well deviation. We are going to just stick on those two wellheads, headers, and well deviation. So make sure you have opened your computer, you have opened our petrel software, and then follow the step I'm going to show you now. Okay, now let's go to our desktop, and here it is. We want now to open our petrel software. So what are we going to do? First, you need to come here, as I showed you, to our how to install petrel software into your computer. In order to start a petrel software, you need to use a loader. Don't just go here and open. So you have here to come here and double click, and then open. You will go to this computer or to my computer. Remember where your folder, your installation folder is, and then open, for example, for me, my installation folder was in drive C, lock disk C. So I have to go down to look where there is program file 86, and then I will go down to look for the folder which is written Scramble. It is here. Also, I need to click on Petrel 2009. I will look to the icon of Petrel P. Petrel. Here it is. Where it is here. So then I will click Run to open the software.
Intromusic.com layout track.